Good day, everyone. My name is Mr. Prosper. If you're meeting me for the first time, and I am a mathematics, chemistry, and physics tutor. So basically, what we do in this channel, we're going to be preparing ourselves for external exams in Nigeria, such as mathematics, chemistry, and physics, basically. Okay. So for today, our video is on chemistry. Calculations on what heat of neutralization and combustions, jam problems actually. So the first question here, let's not waste time, is we have 0.16 gram of methane when burned raises the temperature of 100 grams of water by 40 degrees Celsius. What is the heat capacity? What is the heat of combustion rather of methane if the heat capacity of water is 4.2 joule per gram per degree Celsius? Now, if you see a question like this in your upcoming JAM exam, it's a very simple question. Okay, you should realize that the heat that is needed to raise the temperature of the water would be gotten from the combustion of methane. So using our heat formula, we can calculate the amount of heat gained by the water using the formula delta H. Delta H is equal to MC delta T. So in this formula, delta H represents the heat gained by the sample of water, M represents the mass of the water, C represents the specific heat capacity of the water, and then your delta H represents the temperature rise or drop in the process. So bringing out our parameters, we'll say where M is equal to the mass of water given, as you can see, is 100 grams. And then the heat capacity of water was given to be, I think, 4.2 joule per gram per degree Celsius. Then the temperature rise, which is the change in temperature, was given to be 40 degrees Celsius. You don't have to convert the 40 degrees Celsius because, as you can see, your specific heat capacity is expressed in degrees Celsius. So you leave that. So plugging this into our formula, we're going to have that the heat absorbed by water will be equal to 100 times 4.2 times 40 as joules. So someone should help me with the calculator now. 100 times 4.2 times 40.
16,800.
We have 16,800 joules. So this represents the amount of what heat that that's being absorbed by the water. But then, what's the definition of heat of combustion? Heat of combustion is defined as the amount of heat evolved when 1 mole of a substance is burnt in excess oxygen. So, from the question, 1 mole of methane is 16 grams per mole, but we didn't burn 16 grams. We burned 0.16 gram, and it is this 0.16 gram that is supplying this energy of 16,800 joules to our water. So we can say 0.16 grams of methane, okay, liberated 16,800 joules of energy to the water. But we're not interested in 0.16 gram, we're interested in 1 mole of methane. And the mass of 1 mole of methane is 16 gram. So we're actually interested in the amount of heat that will be evolved if we should burn 16 grams of methane. So 16 gram of methane, let's say X, we don't know. So this represents the amount of heat that is being evolved when 1 mole of methane is burnt. So if you should cross multiply from here and then make X the subject of formula, we're going to have that X would be equal to 16 goes and multiply 16,800. So you have 16 times 16,800. Then if x goes to multiply 0.16, you have to divide both sides by that number to make x the subject of formula. So by the time you punch this in your calculator, you get your final answer. So someone should please press the numerator, 16 times that number. 16 times just this number, the numerator, what do you have? Sorry for the delay.
268,800.
268,000 what?
800.
800. Okay, you could divide that now by 0.16.
1,680,000.
Okay, I want you to call that one the one. One what?
1 million
1 6,
1680
okay.
000.
000 shows. Okay, that's about 1.7 million. So if you should look at your options, the options are expressed in kilojoules. So to convert your answer from joules to kilojoules, you divide that number now by 1,000. So if you should divide that number by 1,000, three of these zeros will simply leave and your answer becomes 1680 kilojoules. And that corresponds to option what? Option D. So if you see a question like this in your jam, this is how you go about it. Thank you for watching. I'll see you in my next video.